Hello everyone, welcome back to our channel. In this video, we are going to learn about LangChain Output Parsers. We are going to understand what exactly is Output Parser, why do we actually need Output Parser, and we are going to see how we can apply Pydantic Output Parser with AWS Bedrock. And we are also understand what are the different way of applying parser in LangChain and how do we make use of it in converting the output coming from the LLM. So let's get started. So what exactly is output parser? We are going to see it with a simple example. So when we have already gone this example earlier as well, which is very simple LangChain example, a chat example with AWS Bedrock, where we are simply chatting with the AWS Bedrock, asking that what you suggest for mild fever, and it will give us the output. Okay, let me run this program and show what I am trying to say. After running this program, if you see, I'm just printing the output coming from the LLM. If you look into the output, the structure is basically AI message, content, additional underscore kwargs, and response underscore metadata. This is the entire structure basically coming from the LLM. Okay. But ultimately what we are interested in the text message that is coming from the LLM. It is present within the content section of the response. So what normally we do, we actually extract that content with the help of response.content. So instead of making use of response directly, we make use of response.content. Okay. So as long as the response coming from the LLM is normal text, okay, then that's fine. So we do not really need output parser. We can simply work with the response coming from the LLM. Okay. But in case if you are actually looking for structured output, basically if you want to use the output from the LLM in dumping data into the database or interacting with a function by passing that argument into a function and calling that function. So in that case, you require an output parser. What exactly output parser does in that case? It will simply check what is coming from the LLM. Let me convert it into a right format, basically a JSON structure with a set of keys that we are interested in, and then we can make use of it. Okay, so we can have different type of output parser in LangChain. So if you look into this table, we have different type of output parser. str output parser, as I told you earlier, that if we want to fetch only the content from the response, then we can make use of this str output parser. We do not have to explicitly write response.content. We can simply fetch that particular message. Then we have JSON output parser. Simply it returns the JSON object from the output. Okay. XML output parser, CSV output parser, and so what we are interested in understanding, Pydantic output parser. What exactly it does? It not only simply parse the output, it can also validate the output as well. Whether the output has correct data type or not, it can check. Okay. So let us see how we can make use of Pydantic output parser with the help of sequence diagram, and then we are going to see the example code and run it. This is the flow. Okay, let me just turn this on the right side. Okay, this is the sequence diagram. So what exactly we are going to do? What we are saying, so user provides a query. Okay, so what we are saying, we are going to send schema to the LLM, saying that in the prompt basically. So normally what we do, we create a prompt and send it to the LLM, and LLM response back. And LLM do not know about what structure we are expecting. Okay, because LLM simply return back the text. But in this case, what we are saying, we are going to send the query in the prompt and as well as the schema instruction in the prompt, so that we can educate LLM saying that, hey, I am looking for the output in this particular format, please give me. Okay, so in this example, this is what exactly this diagram is showing. Send query text, we are preparing the prompt. Okay, in the code logic, we are preparing the prompt. In the prompt, we are actually sending the formatted prompt, basically format with JSON instruction. And in this instruction, we are sending to AWS Bedrock, hey, format the output in this way. And then ultimately, the response will come back, and then we can make use of it. This is a very simple sequence diagram. We are sending the format instruction to the LLM, and the LLM will pass the output and gives back to us. So how we can make use of it? Let us see the example. This is the logic. Okay, So let me just clear this as well. This is the logic where we are using PydanticOutputParser with AWS Bedrock. Okay. What we are doing actually in this prompt, we are sending this particular query. Okay, Anna is 23-year-old and she is 6 feet tall. Basically, what we are asking to LLM, we want to fetch the age 23 and height from the query. So can you do that for me? So for actually getting the response in the right format, we are structuring it here. Okay. So what we are saying, we are creating a Pydantic model as we learned Pydantic in the last video. You can obviously follow that video to understand about Pydantic. That's why I created that video earlier before this. Okay. So here what we are doing, we are creating the person class and the people class. People class is a list of person. Okay. And this is actually a schema basically, which we are expecting from the output. Okay. So this is the schema of the output. And then we are initializing the Pydantic output parser. So for that you need to import right from the output parsers LangChain underscore core.output parser and then import Pydantic output parser. We are initializing this Pydantic output parser with the people. Basically people is the actual class which is making use of the people, basically this one, which is making use of the person as a list. Okay, so we are passing the people schema within this Pydantic output parser, and then we are creating the prompt. This is the system template, basically system instruction to the LLM. In this system instruction, we are passing in this particular schema. Okay, what we are saying that please return this in this way. Okay, return them in the following JSON structure. This is the prompt approach, basically sending the instruction, format instruction in the prompt. Okay, and then this is what we are saying, only include the name and no other information, always return valid JSON that matches this exact structure. Okay, and then this is the format instruction. Okay. Now while initializing, this is the initialization of the prompt. Okay, chat prompt template from messages, and then we are passing this instruction, system instruction with the system role and human instruction with the human, basically the original query. Okay, this is the query. Now after that what we are doing, we are initializing the prompt. Okay, here this is the prompt with the placeholder. Now prompt.partial, here we are passing the value of this format instruction. Okay, where this value coming from the parser itself. Okay, so schema Pydantic output parser is actually extracting the schema and then sending that instruction into this format instruction. So basically we are initializing the prompt correctly with everything, and then we are initializing the LLM model chat bedrock converts with the Nova lit. In order to use this in the AWS Bedrock, you need to enable it. You can check out the AWS Bedrock video that we have created to enabling it. And then we are simply using the chaining approach to actually initializing the chain. And chain.invoke query, we are sending the actual query. So as soon as this query reaches to AWS Bedrock, so AWS Bedrock will understand, okay, this is the query, this is the format instruction. Okay, I need to pass that output in this way. So finally I'm just printing this response itself. Okay, in the similar manner, in the simple chat we have seen, we printed this, but we got a very huge response from LLM where we need to extract the text from the content, right? But in this case, the structure will be in this way. So when we run this program, the output looks like this: people equal to person name equal to Anna, okay, which is an array of person. Okay. So here there is no other structure coming to us. Only that structure which we are passing to the LLM is coming to us. So we can simply see this program. We can run this program. Okay, for the sake of showing. Okay, UV run. Okay, AWS Bedrock / chat with Pydantic output parser.py. Hit enter. Then it will simply take up the query that we have written in this logic and return the response. Here if you see, the response is whatever we sent to the LLM is coming back. Okay. So this is one way of actually parsing the output with the format instruction present in the prompt. Okay, this is one way. The second approach is, which is introduced by LangChain. So the second approach is what LangChain says, that this is what the LangChain says. Okay. So LangChain says that, so one way is doing the prompt approach. Second approach is like there are certain LLM provider basically that suppose tool calling. We will cover the tool calling in the upcoming video. Basically it means that associating the function to the client, okay, to the LLM client. Okay, if you look into this, this is basically the LLM client. this one. This is basically the LLM client. We can actually bind the function to this LLM client, and then we can say to LLM, hey, if you return any response, you can call this function to do further operation. Okay, basically this is or do so that is tool calling basically in a simple sense. The second approach is tool calling. You associate that format instruction, or you associate that parser in the tool calling, and then it acts as an output parser, and finally it will get the response. And third approach is with structured output, which the LangChain itself provides. So here in the documentation, if you see, just go down. This is what the LangChain says that. LangChain says that first approach is tool calling approach. Okay. Second approach is obviously prompt that we have sent in this example. The third approach is using the with structured output function. Okay. So LangChain library has introduced, LangChain has introduced this particular function. And if we use this function and pass that parser, it will simply be able to parse it. You do not have to send anything in the prompt. So let us see this example as well. So in this example, this is a very basic example basically. This is I've taken from the LangChain itself. What it says that this is the Pydantic model, okay, JOC model, and I'm using the base model as per the Pydantic rule, right? And then I'm putting in 3 properties that setup, punchline, and rating, along with the field that we have seen in the Pydantic tutorial, where we are passing in the description. So this description is mandatory and is important. Whatever you write, so LangChain, whatever you write, LLM understand this instruction. Basically, this particular instruction is understood by the LLM, and accordingly the LLM responds. Okay. So once we create this model with this, then we just, this is the normal initialization with the chat OpenAI. Here we are using chat OpenAI instead of AWS Bedrock, because with structured output is giving error. It is not supported by AWS Bedrock Converse API. Okay. So that's why I've taken the example of chat OpenAI here. So in this case, if you see, we initialize the model with this, and then I'm using this function with structured output. So if you look into this example, this is very thin example. We do not pass anything in the prompt, any instruction in the prompt. We are simply making use of a simple function with structured output. Okay. And then we are passing this schema. That's it. Okay. So by passing this schema, it automatically takes care of everything. Okay. Whatever the response returns back from the LLM, it actually Pydantic makes use of it, and then the parsing happen and we get the response. Okay. And then finally we are invoking it with the structured model.invoke, tell me a joke about cats. And then I'm just simply printing the response here as well. Okay. Now let me run this program again. Hey, run this program. Okay. UV run chat with structured output parser.py. Okay. Hit enter. As soon as I hit enter, it will run and give me the response in this structure. You look into this job setup punchline rating. Okay. So we get the structured output from the response. So you don't have to worry about actually explicitly parsing it, explicitly validating it. Everything is done automatically with the help of with structured output. Okay. So there are 3 approaches. One approach is using prompt that we have seen. Second approach is tool calling that we are going to see in the upcoming video. What is tool calling exactly? Third approach is this with structured output, where we just have to pass in the schema, we get the response. Okay. And this is very, very important, because actually in real world building an application, Gen AI application, simply relying on the textual data from the LLM may not help, because ultimately we need some kind of structure from the output, and then we have to interact with multiple different function, third-party API call or database interaction, etc. So where this output parser is very, very important to understand. Okay. So before using with structured output, you need to make sure that you follow one table by LangChain in the chat models. In this 0.3 chat models, if you scroll down, there is a table. Whatever the provider supports structured output, it has a tick. Okay. And those who do not support it, it do not have it. In case of AWS Bedrock, since it is an abstraction on top of different models, so some of the models underlying AWS Bedrock may not support with structured output. So you need to carefully choose this approach with structured output. Otherwise, yeah, you can follow this table and make use of it for output parsing. Okay. So that's it for this video. I hope you understand the concept of output parser in a well manner, and in a well structured manner basically. And this particular repository is code is already pushed, and this is public repository in the Learn for Taraqi repository section. So you can simply check out the link in the description and follow this particular source code and try to run it. And the setup is with the help of UV init command and UV run command as you see to run this program. Okay. So I hope you understand concept very well, and thank you so much for watching this video, and stay tuned for upcoming videos, and do subscribe to this channel if you want to learn more about AI. Thanks. Bye.